Assalamu alaikum wa rahmatullahi wa barakatuh. The last time we were discussing inclined planes, I did this sum that showed us how to calculate the power developed by the Bucky's engine during the climb. Now, before I go on to 6.2 and 6.3, I was just thinking that when it comes to inclined planes, there are different approaches in doing the sum. So I will redo 6.1 now using a different method, a different form of reasoning. All right, so I've made a copy of this diagram. And if you look at this diagram carefully, I'll just make it a little small because I'm going to have to do a little bit of drawings. Right, if you look at this diagram, 6.1 says, if you look at 6.1, we can work out a sum using a different form of reasoning. So if you look at a question, it says calculate the average power developed by the Bucky. So if we have to work out power, there's another equation that we have P is equals to F multiplied by V. So what we'll have to do here is find the net force in the average velocity that the Bucky is doing. Now, the velocity part is easy. If you look at the velocity, we see that we've got 72 kilometers per hour. And if we convert that to meters per second, we divide by 3.6, and we see that it becomes 20 meters per second. So the V part is sorted out. Now we need to sort out the F part. Now, if you look at this, the net force on this diagram, it's what we have to see first. We see that they give us the average work done to overcome friction. So work done to overcome friction is given as there's an equation that we know the work is equals to force times delta x. And the work done to overcome friction is 5,8584 times 10 to the power 6. And we want to work out the force of friction that we have. And the distance that the friction is applied over is 570 meters. So if we have to work out the force, sorry about that, if you work out the force, it will be 5,84 times 10 to the 6 divided by 570. And if you work that out, it's 5.84 times 10 to the power 6 divided by 570. And that gives us an amount of 10245,61. 10245,61. So that is the frictional force of this Bucky as it is going up the slope. Now, that is not all the force that is necessary in this sum, because that if you look at this diagram, if you say we take this Bucky, we see that we can take this force and we can break it up into components. I'm going to just make it a little larger so that we can see what we are talking about. This will be your force related to gravity. This will be the force, the reaction force, the opposite of the reaction force, or we can say it's one of the perpendicular component of weight, and this is the parallel component of weight. Now, what is very important in this sum is that apart from the frictional force which is pushing this Bucky down, this Bucky is being pushed downwards by a frictional force, but it is also being pushed downwards by the parallel component of weight. And because it is moving at constant velocity up the slope, that will be the net force applied by the engine in moving the Bucky up the slope. So what we'll have to do is work out the parallel component of weight. Work parallel, the weight parallel that's pulling this Bucky down. So when we'll have to add that to the frictional force. Now in order to do that, we need this angle theta. Now to work out the angle theta, it will be the same as the angle theta of the inclined plane that we have there. And here we see that here is a triangle that we have. I'll put it in another color. If you look at this triangle, of the slope, the green one. We're looking at the green one now. We see that in terms of angle theta, this 55 is the opposite, and the 570 is our hypotenuse. So if we work out the angle sine theta is equals to 55 over 570, and if we use our calculator, we see that angle theta is equals to 5,5 degrees. Now we've got angle theta, and we see that in terms of angle theta, the parallel component of weight is also sine. And if you work out the gravitational force that's pulling this bucket down, if we work out our weight is equals to mg, which is equals to 1750 multiplied by 9,8. And if you work that out, you see that we have 1750 times 9.8, and that gives us 17150. 17150. And if we have to work out the weight parallel, it becomes mg sine theta, and that will be equal to 1750 times 9.8 times sine of 5,5 degrees. And if you work it out, 1750 times 9.8, 1750 times 9.8 times sine of 5.5 degrees, and we see we get an amount here of 1643 newtons. So that's also pulling the bucket down. So if you look at your net force, your final force, let's just put that right. If you look at our force now, our force will be 10245,61 plus 1643, and that's going to give us, if you work that out, 10245.61 plus 1643, and that's going to give us a force of 11888,61, and that will be our net force. And if working out power, P is equals to F times V. You have to say 11888,61 times our velocity, which is 20, times that 20, and we get, and we change it to scientific notation, 2,38, sorry, we get 2,38 times 10 to the power 5 watts. So that's the answer that we get if we look at the same sum, but if we have to work with our forces that are parallel to the slope. Let's just compare the sum to the earlier sum, and if you look here on the top, we see we get the same answer, 2,38 times 10 to the 5. And in this sum, we see that we had to work out the parallel forces to the slope. So these are two ways of working 6.1 out. Just to compare it again quickly, in the first one, we worked with power is equals to work over time, and in this particular one, we said P is equals to FV, and we see we can get exactly the same answer. So you can do it either the first way or this way, and both ways will be acceptable answers in doing the sum. Okay, that's all for today. Thank you.